Okay. Thank you very much for having me. Really appreciate coming out here to be with you today. So from a company, Armour, we're a team of technically skilled architects, I would say, from all over the world. There are currently 18 of us. And what unifies us and unites us is the belief that an architect is an individual who unites creativity and technical ability. So it's this unisys of technology and creation. And we really believe these skills are not mutually exclusive, but rather they're both necessary in order to produce the types of innovative and performative buildings that, that our cities require today. So we believe in order to improve our buildings, it's not enough to merely provide design intent. We can't just give across drawings that someone else works out. So these drawings that are interpreted by others on site. Rather, it's really necessary, and we're obliged to fully engage with the means and methods of construction, of manufacturing, assembly, logistics, and installation. We need to understand and engage our supply chain from concept design. So I think, let me skip forward. I'm using the wrong one. Okay, so all right. So to engage with the means and methods. So here you can see some examples of our work. Everything we do is comprehensively modeled in 3D. So we incorporate 3D laser point cloud scanning in every project to progressively verify the work as it's built on site as we go. So this is a major shift because this allows us to completely change the way that we detail design our buildings and our connection brackets, for example. To give you an example, by combining 3D scanning with a just-in-time fabrication pipeline, we no longer need to design complicated three-way adjustable brackets. Rather, we can design simple laser-cut plates, each of which is slightly different and takes up the tolerances on site. So, as the concrete and steel is erected, we can import the point cloud scan onto our model and adjust the model like you would an off-the-rack suit before releasing the parts to manufacture just in time. So furthermore, we remove as much as possible the need for 2D drawings by incorporating the instructions for how to assemble the systems on site by actually laser cutting them or engraving them into the materials themselves. These are some of the recent projects we've just finished in Sydney this year. So 200 George Street from Mirvac and FJMT Architects. This is Grosvenor Place for Harry Seidler Architects. But everything is designed for manufacture. Everything is prefabricated and sent to site. And I'm going to talk to you today a little bit about how we've recently used a 3DEXPERIENCE platform to detail design for manufacture almost 3,000 ceiling panels for the Wynyard Walk project in Sydney. What is really important to notice about the team and as we work together is that I think what makes us really different is that everyone in the office writes code. It's not enough to just model. It's not enough to put together assemblies and parts and think through the building process. In order to work on the types of buildings that we work on, it's absolutely crucial to engage with the means of production and to be able to communicate with them. And often that means writing code and sending files directly to machines, sending G-code directly to machines. So it means a different kind of engagement with the computer, a different kind of engagement with our materials. So Wynyard Walk is a landmark development by Transport New South Wales. It's designed by Woods Bagot Architects. The project provides a pedestrian link between Wynyard Station and the developing CBD Western Corridor Barangaroo. The walkway allows pedestrians to get from Wynyard Station, which is here, down to Barangaroo, avoiding steep inclines and road crossings. So the project increases the entry and exit capacity of Wynyard Station, caters for the Barangaroo development. So expected for up to 23,000 office workers and 33,000 visitors per day, which is happening now. So we consulted to the contractor CPB at a critical point in the project due to time pressures and the public nature of the project. So our task was to manage and execute all of the detailed design of the stainless cladding, the end result being to deliver a fabrication-ready package of over 3,000 perforated folded stainless panels and lights, so each of which was necessary to include integration with services and coordination with other works. What made this particularly challenging was the enormous time pressure, complex ceiling layouts, all designed in 2D, and unresolved system design that we inherited. So what we needed was an efficient solution in order to meet the requirements of the project. So the project needed a parametric model and that was flexible enough to respond to the ongoing design challenge. These resulted from having to coordinate with other trades during construction. The model had to incorporate and accommodate as-built primary structure, the glass-reinforced concrete wall cladding, and having to interface with the ceiling, constant and ongoing changes in the panel layout due to modifications to the facade mullions and setouts, changes in panel perforations. We also needed to control and output assembly and part drawings and instructions for manufacture, and then also keep track of comprehensive bill of materials. So you can see the level of detail that we go down to. So every single pop rivet, VHB tape, everything is modeled and accounted for. And that's what it's so fantastic. So we chose 3DEXPERIENCE for the following reasons: its ability to integrate engineering and fabrication, the fact that it's parametric, it's a part and assembly paradigm, its sheet metal capabilities, the generative drawings and drawing automation, and most importantly, the fact that it's scalable. We can have, we could have 12 people working all at the same time on the same model on thousands of parts and all running off a standard laptop. And it's not possible within a certain time frame to just draw this. We have to automate it. So all of the automation of the geometry and the generation of knowledge reports in order to track assemblies through fabrication. So this allowed us to produce a highly detailed, accurate, and comprehensive 3D model of the entire scope. And we were able to foresee problems before they arose. And importantly, it allowed us to minimize the number of part drawings. So by providing fabrication-ready 3D geometry directly to the fabricator, so 3D step files straight out of the computer, straight to the fabrication, just in time for manufacture. So we're able to limit the 2D documentation to high-level assembly drawings only. And this was really important because it enabled us to save a huge amount of time both in the office and in the factory. And it also, importantly, it removed any error from misinterpretation of the 2D documents. So through the 3DEXPERIENCE platform, we're able to automate and instantiate the geometry in the drawings using EKL and VB scripting. And due to the time pressures on the project, because of the time pressures, it was necessary to release all of the fabrication in batches. So 3DEXPERIENCE Lifecycle Collaborative Apps allowed us to coordinate and track all of those numerous batch releases through its ability to manage versioning, maturity, and revisions. So in the end, there were more than 2,000 stainless steel perforated panels, 600 primary and secondary light curves. And importantly, more than 50% of them were unique. So it's a huge amount of unique stuff that it would just not be possible to draw in any other way. And generally, I would say we're software agnostic. We use everything and anything in order to get the job done. But there are some things that you just can't do any other way. So what I want to leave you with today is a problem within the building industry that we see a lot, and potentially, hopefully, a solution, something to think about. So buildings today are almost, if not more, complex than cars and airplanes. There's as many, if not more, parts. There's more stakeholders. It's a completely fragmented industry, each of which has to communicate through 2D paper-based drawings or PDFs. It's a nightmare. So let me give you an example. But the way we're designing them is really antiquated. So for example, let's imagine you're tasked with building a car. So we have to make a car. So we've got a new car we need to make, and I say, okay, what we're going to do, it's a brand new, let's say it's a brand new C-Class. What we're going to do is I'm going to cut a whole bunch of sections, orthographic drawings through the car. I'm going to give you all the drawings. Just lay them all out on the table. There's a whole bunch of A0 drawings. Here's one really important horizontal section straight through the middle of the car and the engine bay. Go to work. Let's start putting it together. It doesn't make any sense, right? It just doesn't make any sense. So why do we build buildings? Why do we design buildings like this? So I think, you know, in order to move from 2D, from lines on paper that are representative of objects, the relationships between objects that have to be interpreted many times and redrawn multiple times by people in different offices on site, doesn't make any sense. Moving to a collaborative platform that's based on parts and assemblies makes a lot more sense, and this is exactly where we're heading and want to head, and this is exactly why we're moving over to 3DEXPERIENCE. So that's what I want to leave you with. Thank you very much for having me.